Hello, does this work? Can you hear me now? Holy crap, I did not know that it was off. I swear to God, I thought it was on and everything was working. I even double checked everything. Anyways, I've said so much about this tool and how it's supposed to be a tree-like tool, and I was talking about um, how what we wanted to do is that, oops, is to have it list things in a folder. Oh my God, I am so sorry, people. I am really, really sorry. I didn't realize that. All right, I'll do a quick recap. Essentially, we want to talk about asynchronous and parallel programming, right? But to do that, I'd like to build a small application that I can't believe I've been doing this for 30 minutes without realizing I had no sound. But essentially, we want to build a small application that shows us when and how we can use it. To build a small application, I chose Tree, right? A utility that you can install with brew install tree, right? That will show you essentially everything you have in a directory tree. So if you call tree with no parameters, it will just show you everything you have, which is fine for a small folder like this one. But in the one that I wanted to test things out, which is var, it should take about a second or so after listing a bunch of crap. So if I call time tree var, it takes like 842 milliseconds. The idea was that we will build something that does just that, fulfills just that use case, and we'll build it first, synchronously, blockingly, and then after we do that, we will build the same thing in parallel, right? Or first asynchronously, and if it's not fast enough, then we will do it in parallel. Um, so far, what I built is a very small application that I'll show here right now. In fact, I can use itself to show itself, right? That lists all of the things that are in the current directory in the dot folder. The plan that we said was if we call oak, and I'm using oak because it's a kind of tree, and well, tree is a tool I'm trying to mimic, then we should see some outputs. However, and at the beginning of the stream, I tried, or I thought I did tell you, but I didn't. I just told myself that I was gonna limit the scope of the tool. Why? Because tree does this nice thing where it, essentially, yeah, puts everything in a tree, so you can see the leaves and the branches going from, like build to default to source to bin to main.exe. And I thought it would be too much time for us to spend on that. We can take a look at how to do very nice printing on the next stream, where we can talk about command liner. In this one, we want to talk about asynchronous programming. So we want to take a use case that is much simpler in terms of user experience, quote unquote, and make it fast. So I figured maybe what we really want to show, we want to mimic is find, right? You say find dot, then you get all these files, and they look like this. And sure, it's not as nice as tree, but it's still usable for finding things. I mean, it's called find, right? So you can just say find dot, and of course you can do a lot of interesting filtering here. But worst case scenario, you can just grep stuff and say a dune, and it will just boom give you the things that you're finding. So that was a little bit of the first 35 minutes of the stream in 2 minutes, I guess. The directory structure for this project is very small. We have a package called bin, which stands for binary, that only will call a package, a module that we need to define somewhere that will be called oak, that will have a function called run. And the distinction here is that we want to keep the binary packaging separate from the actual logic of the application. This is just a pet peeve of mine. I like to keep packages very, very small. So I figured that we would start the oak package, right, by saying there is a run function, and we can very slowly try to get um, the current files and try to pipe it over. And if you watched a little bit of the past 15 minutes, and I'll try to rewind, you'll see that we began right with some hard-coded paths that we essentially slowly were replaced by an actual call to read there, and read there returns as this array of things. And then we said, okay, we need a list, and then we return just a list. And then after that, we just said, well, the paths have this long beginning, right, which is the full current working directory, so maybe we can use dot. And dot seemed to work just fine. And then we kept working a little bit more, and we said we're going to append the directory to every file, so that you can see, instead of seeing an output that says that, instead of seeing that, we would see an output that says okay, I can't get that to work. Something more along the lines of this, where you have all the files beginning with dot slash, which is, hey, this file is relative to this current location, and so on. And we continued by saying, I forget. Okay, I think this is where we were. We continued by saying we could append these two strings, file name and directory, right, with this slash in the middle, but we probably want to support this in other platforms that use different separators, like backslashes in Windows, for example, right? So perhaps we can use the file name module, which has a function called concat, right? That will take two paths and will concatenate them together. So if we do that, boom, then we get the exact same result. And the setup that you see here in my terminal is on the left-hand side, right? All the stuff over here that I can't really highlight only vertically is the editor. On the right, on the top, is where we will be running the program like we do right now. 1, 2, 3, go, boom. And below, it's an automatic building that happens thanks to Dune. And Dune is the build system that we'll be using for building this recent native application. And okay, so far we have identified all the files, right? And we are able to just print them out. But if we wanted to see the source, then we need to go into source and then run the same thing again for the next level, and then the next level, and so on. So that's not very handy. If we remember, when we called find dot, this thing went through all of the levels automatically for us. So that's what we should do too, right? Which means every time that we call oak, right, it will list all of the files that we have in a particular folder, right? And then it should list all of the files of all of the folders inside of a folder. What does that mean? That means that whenever we call, and I'm gonna just do the same things here, sys.readdir, and we get these files back, we should check if any of these files is a directory or a file, and if they are a file, right, then we just leave them there. But if they're a directory, then we kind of want to just, find all the files inside of that directory, and so on and so forth. And I hear someone say recursion. Yes, exactly. We need to recurse. Yeah, nobody actually said recursion. I thought it would be funny to say that. Okay, so cool. After we read this, we need to mark files as either files or directories. So we can take a look at what does the sys module have to offer us, and we'll find that inside here we have this little function called isDirectory, which is interesting, right? We can essentially just try to call isDirectory, and you'll see the signature here is it takes a string and returns a bool. So if we say dot, this will be true. But if we say dot slash Doom project, which is the file where we define this project in, it will say false. So we have a predicate, right? A function that based on the input that we give it tells us whether it's true or false. That sounds to me that we can essentially go through a list and tag things as directories or not directories, which I kind of like, to be able to separate these things together. So maybe we want to take a look at the list module and see if there is any function that looks, like this. We're looking for something that takes a list, or rather, takes a function from one element to Boolean, right? And it takes a list and returns something that looks like two lists. It could be in different shapes. So reading this might be really awkward for some of you. Don't panic. It will be okay. So Functions are normally set in parentheses. So this init, for example, takes a number, and it takes a function that will receive a number and come up with some element. And if you give it these two things, it will give you a list of those elements, the elements that you come up with this function. So you can think of this as your generator function. All right, so I see somewhere here we have, looking on the right-hand side to see the two lists together. And okay, we have this one over here. It says, it's called partition. It takes a function that goes from some element to Boolean, like our is directory function, and it takes a list. And based on that list, it returns a product, a tuple of two lists. So some of this will be directories and some of them will be not directories, essentially. And that's, in my book, that sounds really good. So we can essentially say that if we begin with this string, and I'm going to rely here on Merlin, essentially the language service provider, language LSP, language server protocol for a camel, but it's not really LSP. It's from before LSP to give me information about the types of the parts of the program that I'm writing. And all of that information is going to happen down here at the bottom. I don't know how to do this. I think it was like that. Yeah, oops, nope, that's my mouse. My mouse should be somewhere here. Okay, that still didn't work. I don't know. Let me just try one last thing. No, okay, that's not going to happen. But if you look at the bottom left of my screen, you'll see that it says string. And that might not be too obvious for those of you that, oh, amazing, Pixel Hero correcting me. Thanks, dude. And essentially, for those of you who have more modern editors than I do, you'll find your type information much closer to your variables. But I've grown used to this, so please forgive me and bear with me. And I have a small command here that if I, essentially it's a key binding, that if I press it, it will tell me the type of the immediate next expression. So if we begin with a dir, which is a string, and then we call read dir, then we have an array of strings. And then if we call to, oops, sorry, my bad, to list, then we have a list of strings. I can go back as well and say that we went from an array of strings to a list of strings. And then if we, call one more, we'll continue having a list of strings, because we're not really changing what a string is. And if that is confusing to some of you, we can come in here and say the signature of concat really is takes two strings and returns another string. So if this map, right, takes one list of string, it will return another list of string. And the types might not be very helpful right now, and I think we can do a lot to make them much better for this use case. So we'll do that in a second. But first things first, we need to split this list into one side and the other, the directories and the rest of the files. And we can do that with list.partition. Notice that right now I'm not going to pay attention to this line. We'll take care of that in a second. Essentially, what I want to do is say, what will the type be if I pipe the result of this thing here into a partition function that takes sys.is directory as a predicate? So I can start over and go oops, my bad. I can start over and say I have a string, and then when I try to move on one level more, I immediately see that there's something weird. I can't step one expression at a time. So this tells me that there's some type that's wrong somewhere. And the compiler, of course, might complain, but I haven't saved the file. So if I save the file now, the compiler will complain. And it says, this expression has type string list to string list on line 11. So if we go to line 11, and that makes sense, this expression does have the type. It takes a list of strings, returns another list of strings. And it says, but an expression was expected of type string list and string list to A. And this is the weird part. For some of you might be wondering, what the hell is that thing, right? And as it turns out, partition itself returns a tuple of two lists, which means that whatever we get here, it will look more like dirs and files. And I'm going to have to add braces around it, so bear with me for a second. And this means that this thing over here, right? Oops, if I save it. Oops, sorry, has a syntax error. I need to remove this. There we go. This thing over here has no idea what the type is. Okay, so essentially, what I can tell now, and I know this because I've run into these problems before. It's not something that should be immediately obvious, is that this call is breaking things. So I'm just going to put a semicolon there and just go that way. I'm going to ignore this thing. I can also comment it out. I think commenting it out might be better. So if I save, you'll see that the auto formatter did something for me there. I'm going to have to make this a little bit smaller so it fits in one line. But in reality, the 80 lines should be there. As you see, the little column in the middle. So if I go one more up, I think one more to the right, yeah, one more to the left, we're exactly in the 80 columns there. By the way, you don't have to use 8 columns. You can use as many as you want, but I would recommend you to use as few as you can, because normally the decisions that you make with the things that happen here on the right are based on inputs that you have here on the left. So the closer you have left and right together, the better. It's easier to go up and down than to go left and right, or at least I found so. But yeah, we need to speed the hell up because we have an hour and a little bit more left, and I don't think we're gonna reach async otherwise. So we have these files, and this means that we need to essentially print these files, so we need to return them, right? And they are a list already, and we have these directories, right? Now we don't really know which one is which right now. We don't know if the left ones are directories and the right ones are files. We just know it's just two lists of strings, which is one of the disadvantages of its directory and partitioning lists. It doesn't let you tell you which one is which. We need to go into the documentation. So I actually never remember, so we'll go into the OCaml docs and take a look at that. So if we go into OCaml, and I already have this bookmark here, we can just, normally you can just say OCaml docs list and it will take you, and voila, I already have the page open. And partition, as you see here, returns a pair of lists where L1 is the list of elements that satisfy the predicate. So if the function returns true, they're going to be on the left. If the function returns false, they're going to be on the right. Great. So the first ones are directories and the second ones are files. So the next thing that we need to do here is print the files and take each one of those directories and go through them, recurse, right? So we need to find all of the files inside of all of the directories, inside of all of the directories, and so on and so forth. And what we can do here is, because we want to join all these lists together, we're gonna say I'm gonna have some files, right? And I want to concatenate the result of all of those files with the result of taking each element of this list, right? And I'm going to call this dir prime. And wait one sec. I'm just going to say, all right. So we want to take each one of the elements of these dirs, of these directories, right? And we want to say we need to add to this directory the current directory. So we can do filename.concat, right? And let's say dir. And then we need to call find all on each one of these directories again. So we can say list map find all. And don't worry about the indentation here. As soon as I save this file, it should be fixed for us. Okay, so I have a parenthesis that's wrong there, but if I save it, there we go. Cool. This is fairly straightforward. The last thing that we want to do is just add to each one of the files the file name that we had before, and we can do that fairly easy as well by essentially just doing the same thing that we did before. Oops, file name. And this thing that I just did is equivalent to having a small lambda, right? Where you call concat here with this. Get used to it. It's super awesome, and it lets you write much less code that does more things. Okay, so essentially, if we follow the errors, we'll see that there's something called find all that is, Dune is doing the building on safe. You can pass it watch, and it does the automatic rebuilding of the parts that have changed. It's really fast. And if we look at the types, we'll see that these are some files. And then if we map over the concatenation, then we have some more files as well. And then these are some directories. And then if we map over the concatenation, these are some more directories. And then if we find all, then these are all of the strings. And if we take these two lists and we put them together, then we come up with a new list of strings as well, which is great. The one problem is that find all doesn't know that find all exists unless you specify that it's going to be recursive. There you go. So if we say that, then now we have a type error, right? And we can take a look at what? In line 10, it appears that the result is expected to be a string, but in reality, we want it to return a list of strings. So after we do this, we get that the directory is a list of string. I'm looking here on the right-hand side, and I see line 16. Something is going on. So I go to line 16 on the left, and I say directories is a list of strings, and then mapping over them is still a list of strings, and then finding all of them, it's a list of strings. And that's the problem. This is a list of strings, right? And this is a list of strings. So what we can do here is just spread this list over there. Boom. And then we have no errors. Alternatively, what we could have done is call concat at the end of this. But because I like piping things, as you may have noticed, we can just call concat in that way. And everything should be the same. Okay, does anyone want to make a bet of what should we see right now? No, this is unreasonable. Satan Tree, you are my nemesis. You have said the thing that I was not expecting to be said, or I mean, it was pretty obvious that someone was eventually going to say it. By the way, if it's so unreasonable, you should totally follow it and call me out on my bullshit. Anyway, I'm going to run this, and I expect it to go through all of the directories and show all of the things. We can verify that it works by counting the amount of lines and in respect to the amount of lines that find will print. So if we do this, there's something that we have wrong. What does this mean? It means that, I think, right? We have tried to open some directory called install somewhere. So let's define and let's grep for install and see what we find. So there is a folder called install here. Sorry, install. But for some reason, we have no way of, right. Look at that. My guess is that what's going on here is that we are taking the directories and we append the relative path from before, and this path will continue to grow, right? And then we call ourselves with each one of these paths, but there is something that we are missing, and that is at this point, right? Whenever we read the directory that we're reading gives us the names of the files in a relative fashion. So we can confirm that by essentially calling read there, right? And saying, give me the files inside of build. There you go. And that kind of makes sense. Why? It makes sense because we are losing the information of what the directory where we called readdir is before we partition. And I think, if I'm not mistaken, we can easily debug this. We can just, I mean, we have a function that will print files. We're crying out loud. People, we should be able to do this, right? File print, and then we'll do dir, and then we'll do the same thing for files, and then we'll do print the printf current dir, and we'll say dir. Sorry, this should be dirs. And of course, we are going to use the printf module, and because we don't want to use the return value, we can use iter. That is like for each. Let's iterate over a collection. And because we're inside of the module file, we don't need to reference that, and it should build, and we can close that thing and run it again. And we'll see some output, some, I don't know how much. All right, so the current directory is built, right? And then, oops, my bad. The current directory is dot. I need to add a new line there. 1, 2, 3, go. And then we have all these files in there. And when this tries to recurse, it will fail at reading at this point. So we probably want to do the print before. And then once it builds, we run it, and we'll see that current directory is dot build, right? Which means whenever we call is directory, we're really just calling install instead of appending this to the path. So one easy way of doing it is just taking this little pipe there and shoving it in the middle of this other composition. So we actually will take a look at what path we're going to be adding the current directory to each one of the paths before checking if it's a directory or not. Not only we do it once, I mean, we were doing it once for each one of the elements anyways, but now we will do it on the right paths. So this is saved. If we run this again, we'll get a lot of outputs. Oh my God, do you see that? It's printing all of the stuffs. Even the stuff that we don't care about. Oh, amazing. Okay, so let's remove all of these things from here. Right? Let's just keep it tight. Boom, boom, boom. There you go. And if we save and it builds, we can run this again. And voila, we have our very small recursive file printer. It's not super elegant, right? But it does the thing it needs to do. So now we can check. And if we do the lines that we print 119 lines. And if we do find and we do this, we should see the same amount. But we see more. Why? And I actually already know the answer. I picked it up when we were testing this. And is the find actually shows you the folders as well. It doesn't skip the folders. So essentially, we could just add to these arrays, to these lists, we could add the names of the folders. So for each one of them, we get all the files, we get all the folders, but then for each one of the folders, we'll get all the files and all the folders inside those. If this works. Okay, we're missing a dot there. There we go. Cool. So now we can run this again, and we'll see it's 117 lines, 177. And if we run the new compiled, we should see, what? What is going on? What are we missing here? Petition to add oak ignore. Exactly. All right, so we can do something cool here. We can say there would be, let's save all of these files on A, and let's save all of these files on, on B, and we can diff A and B, and of course the ordering is different. Sorry, and we'll sort the inputs into B, and we'll do the same thing for find. And now if we do A and B, they should have one difference. And the difference is that we have one file that is a dot, and we're missing the dot. That means in here, we are missing the dir. We're missing the actual first directory that we go to. And this, of course, has to be a list because we're trying to concatenate all of the lists together. If you want it to be a little bit more, I don't know. I think this could look better. You get the file, you get the dir and the other dirs, and we can also rename this. Yeah, no, that should be okay. Okay. So now if we do this thing again, if we say, we're just gonna count the lines. Oh my God, we get so much more lines now. Jesus. Let's see why. Find, let's get all the stuff with find, and let's get all the stuff with oak. And then we do a diff of A and B. Huh. I wonder if A and B has repeated lines. No. 179. And then A, that's 179. What the hell's going on? What am I doing wrong? Am I doing something wrong here? So when I call find, I see this many lines. And when I call oak, oops, I see this many lines, 236. Let's see what we actually output. So we have oak, install, and then at the bottom, no. I wonder if we're not ignoring the swap files. That will be terrible. I mean, they were there. I honestly have no clue what the difference is now. Huh. So what we can do is check that the content is exactly the same. If we sort all the lines and we check the MD5 sum, we will check the essentially the hash of all the content sorted is the same. And it's the same. All right, you know what? I don't trust WC anymore. I will trust MD5 now. If anyone has any complaints about this, please let me know in the comments below. And yeah, I'm gonna drink some water now. 1 second. Cool. So now we know that our tool, right, with the very small thing it does there, we can add a command. We can say add. What did I change in the OK install? Oh, okay. We can add OK install and source being main, and also the plan. No, and also the rest of the sources, right? Which is really just one more file. And we say commit live stream. Okay, no. First MVP or MVP. It kind of does the thing. Oops! Don't look at my password. All right, good. It's there. It runs. We can remove A and B, and now we can do a little bit of stress testing. We have a tool that works. It's very straightforward. It doesn't do much, but it would be pretty nice to know that this tool actually works very well in with a larger input. So if we use find var, we get a lot of results, right? And I wonder what would happen if we go to var, right? I think we should go to var first, though. Okay, so I'm going to do something that I don't normally do, and I'm going to use the install target. So now we have oak available as a binary, and we can use it from any directory. Normally I do that after I committed something to master, which I guess I just did. Anyways, yeah, that works. So now we can go into var, and we are inside of this folder that has a lot of crap. I mean, I have no idea who these people are. Jabber and mobile asset and demon. Who's called demon? Probably friends of Satan tree. By the way, if you like any of this, please follow along. There will be a lot more events coming up that we'll try to schedule with events, right? There's another one happening tomorrow where we'll be adding some more features to this very command line utility using command liner and logs and FMT. But anyways, we're inside of this folder, and if we do find there, right, and we check the MD5 sum, then we still see a lot of permission denied, which is worrying. And if we run oak, and we, oops, sorry, yeah, if we run oak with the same command, then we should, we get even worse permission denieds. I guess the list for for the permission denied that we get in find, this is not too bad. All right, so I need to come up with a different set of examples. So I'm just going to go back into the repository, and I'm going to actually use an example from Cactus. Stera. And inside of the example folders, if I do oak sort line count, you'll see that we do have a bunch of lines, and it takes some time. And if I do find dot, then we get the same amount of lines, and it also takes some time. But just to make it more fun, we're gonna copy some of these folders inside of themselves, actually between each other. So we have even more files everywhere, right? So we're gonna copy series inside of blog, and then we're gonna copy blog inside of series, which also has series right now. So if we run this thing, find dot, and then oak dot, you'll see that it takes some time. So if I run this with time, you'll see that it takes, oh, this is still really fast. I need something slower. It has to be much, much slower. And if I run it with find, yeah. Damn it, why is OCaml so fast? All right, so I guess we're gonna have to, we are going to have to do something about it. We're gonna have to copy these things a few more times. And we're also gonna copy, actually, I'm gonna run cactus build, which is gonna take forever, I think. Yeah, I know, it's just too fast. Nice, and I'm gonna copy the compile targets inside of the blog, and then one more time the blog into the series. And into one of these files. I don't know. These are just dummy files everywhere, but they're about 64 kilobytes each, and we should have a fair amount of them. So the timing things now take some time. Look at that. Damn it. I think the sorting took the most of this. So I'm just gonna call, I'm gonna send everything to dev null. I don't wanna see the output, I just wanna see the time it takes. And now we can do oak here. All right, so I could say that find is about twice as fast. If you disagree with me, speak now or be silent forever. Is that the way we do it? We say it. Yeah. So this is about 100 milliseconds. Like if we do one more copy of blog inside of series, and 2019, then I'm pretty sure it's going to take a little bit over 100 milliseconds. Yeah, good. You can see it varies, but it's no faster than 100 milliseconds, and that's good. It's good because it's enough for us to try to make faster, but also it's not that long that it will actually have us waiting every time we call it. And God, like find still just cracking at it very, very fast. All right, so this is where we're gonna start talking about doing things asynchronously. What the hell does it mean to be asynchronous, and things like promises, right, or futures. If you haven't worked with futures or promises before, worry not. They're not really like threads. They're not really like processes. They're just a value. It's just a data structure, right? That it's held somewhere inside of a library, and that it's executed in a loop. Normally, when you talk about futures or promises, you have an event loop that runs somewhere that checks for things that need to be executed and executes them. And because I'm not an expert in this matter, we're gonna not build this from scratch. Instead, we're gonna use a library. And the library we're gonna use, it's called LWT. Oops, that's the documentation. LWT. You may recognize this thing over here on the left from the logo of the event, which I borrowed. I hope people from Oxygen are not mad for the publicity. Okay, so let's do something first. I'm gonna just move it on to the side. Boom, 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 boom. Let's read what the hell do they mean when they talk about a promise, and then after we're done with this small example, hopefully what we will be working with will be sort of obvious. And hopefully, right? So a promise seems to be a placeholder for a single value, right? So it's something that holds the place of a value for the value itself, which might take a long time to compute. So speaking roughly, a promise is just a ref, and a ref, if you haven't worked with them before, is the way to make mutable references in OCaml that can be filled in later. So it's a ref that right now might not have the value, but that can have the value later. Okay. To make them precise, here is how promises differ from refs. A promise might not have a value yet. Okay, we get that. It's okay. It's a promise in this state. It's called pending promise. So when you start a promise and you don't have the value, it's a pending promise, which makes sense. I promise you something, and until I fulfill it or break my promise, cancel, then I'm not really gonna. I'm gonna be pending my word. Writing a value into a promise is called resolving it, and this starts to look more like JavaScript lingo, where we have promise and you resolve it or reject it. And a promise with a value is called a resolved promise. Each promise can only be resolved once. Okay, so it looks like we have this box that will hold some value that we no longer have, and we specify how to fill the box with some value, but because we don't know how to when the value is going to come in there, we just give the box to people, and then at some point, whenever we come up with a value, we resolve that box, and we just put the value in there. And it's possible to attach callbacks to a promise. So they will run when the promise has a value. That is, this is Latin for id est. And yes, I speak Latin. No, I don't, but Spanish, I guess. When the value has been resolved. If the promise is already resolved when a callback is attached, the callback is run almost right away. So maybe, a few microseconds later. If the promise is pending, the callback is put into a list and waits. So it really looks like if we jump back to the terminal, I'm just going to open a new file here. Whenever you make a promise, there's just, I'm just going to use the recent syntax. Whenever you make a promise, you have something like this. Promise, it's either like unresolved, right? Or pending, sorry. And then resolved, and then you have value, and then callbacks. Right? When it's pending, it also has callbacks. And let's say we have a function called off, right? That makes a promise. And then if we take some function f, then this thing will return a promise that's with 0 pending callbacks, like pending and then no callbacks. And then, oops, this should be pending. And then as we add things to this promise, like let then with a function or promise, then this thing will just be like pending. And then, I mean, actually, okay. I mean, we're here, so, right? If it is pending and it has some callbacks, then we will just add one more function to the callbacks and keep it pending. And then if it's resolved, then it has a value, so it will just call the thing with a value. More or less. I mean, it's not really how it's implemented internally. Why? Because this one here is completely immutable. If you get a pending, then there's nothing in the world that's going to make this thing change behind behind the hood. But the promise library is built so that whatever function you use to come up with a promise eventually changes the value of the promise from pending to resolved. So while this might help the understanding, like a very, very rough, naive understanding, it's definitely not the way it's implemented under the hood. And if anyone knows more about how LWT works internally, please call me out of my bullshit. We're trying to stay reasonable here, as Satan Tree likes to point out. And yes, Pixel Hero, we like quick in category theory. One sec. Water drinking break. So yeah, what it says is that promises are some optional write once references, right? So they can be written to only once, and they don't yet have a value. They store a list of callbacks that are waiting for a value. That looks a lot like what we were trying to model. The waiting callbacks make promises a natural data type for asynchronous programming. For example, you can ask LWT to read a file, and LWT immediately returns you only a promise for the data. You can neglect this promise for a while, and you can do some other computation, request more I/O, which stands for input/output in case you were wondering, or also infrastructure and operations in some companies. And at some point, you might decide to attach a callback to the read promise, maybe several of them. Like you read one file, but you want to do a lot of things with it. In the meantime, the read operation is running in the background. Once it finishes, LWT resolves the read promise by putting the data into it. LWT then runs the callback you attached, all of them. 1 second. Sorry, thanks. One of those might take the data and ask LWT to write out to stdout, like print something out. And this is starting to look a lot like what we want to do, right? We want to read some files or some directories, and then we want to write stuff to the terminal. LWT gives you a promise for that too, and the process repeats. So if you have a promise, then eventually, I mean, you kind of are stuck with promises. I think Pixel Hero pointed out before, monads. Exactly, yes, that. One of us might take data and ask, I already read the sentence, sorry, forgot about that. So yeah, LWT has a small amount of syntactic sugar to make this look as natural as possible. We're not gonna use these things, not because they're bad, they're really good, and maybe you should take a look at using them, but because I don't quite understand the setup for pre-processing yet, so we'll skip that. And Pixel here is asking, do they differ from JS promises? Can they be canceled? Actually, yes, and there's a few things about them that we can learn, but I don't think we need to know that right now. So I will say yes, RTFM, and we can talk about it later. How does that sound? Good? Bad? Give me feedback. I'm gonna rank the each one of the streams later with an NPS, Net Promoter Score, and people will be like, "Oh, he curses a lot" or something. Anyways, so essentially we want to use LWT to read something, and then we also want to use it to print something. And from this example, it looks like there's something called return, and there's something called run, and there's a module called LWT main. All right, let's just make sure that first we have access to these modules, and then we'll try to figure out how to make this thing happen. So if we go into our open module, voila, we already have this in there. Sorry about that. We already have the dependency, and if we go into our oak, the Dune, we can say, oops, my bad. We were not using any of these dependencies. So pretend you didn't see that. Oh, okay. So this is the oak.dune file, and there's no dependencies, so we can add new dependencies by saying libraries and saying, okay, we want to read files, we want to do it with LWT. So let's say that and see what happens. Does it build? We have a problem there. Cool, it built, great. Now, because it built, we have access to the module, which means inside any function, we could just do LWT, and we have stuff. Okay, so the first thing we want to do is read a file. How do we read a file? Apparently, there's a module called LWT.io, which we can look here on the left. The docs are pretty thorough. I gotta say, Anton Bachin, you've done a really good job at documenting this thing. I'm not sure what was there before, but whatever you've added is whatever. The final result is really nice. I like it. And in here we will have a bunch of functions. I'm gonna make the output a little smaller. Ulrich, if you're watching, I hope you're not watching your phone because I need to be able to scan more content. And essentially we wanna do something like this. We wanna read there. Is there anything like read there? Let's take a look. Read. Reading, read char, read charge, read line, read lines, read into, read value, printing. Okay, we're getting an idea of how much stuff we can do and what else is in here. File utilities, open file. I don't see what we want. How can we list? Lines of files, input integers, list there. If we search for there, do we get something there? Open temp file with temp file directory access. Okay, we start over. So there's nothing in here. But what I see is that there is something called LWT Unix. And for example, here, right? So maybe we can look at it on the left. Yes. Yeah, I'm sorry about that. We'll make sure to have I'll have a bigger resolution, I guess, later on, so I can have bigger fonts, but also keep more content. We'll strike a balance, we'll do. So in this module, LWT Unix, there must be something we can use for reading a directory, right? We have sleeping, we have file descriptors, we have blocking, whatever blocking is, and abortions and process handling, and basic file input and output. What the hell's going on here? Read from file descriptors. Okay, let's just search for there and see what we find. Sorry. Oh, look at that. Files of directory. So if we call files of directory with a string, it will give us an LWT stream. Let's begin with that and see where it takes us. All right. So instead of sysread, we want to use LWT Unix dot. And this module doesn't exist. Why? And I'll skip the details, but essentially, whenever you want to use a new module that is some name underscore some other name, a rule of thumb to try out will be to try to import a library called LWT dot on the other name, Unix. And I'm guessing that because it's Unix, we're going to need the Unix module here as well. And this sort of broke the compatibility that we were trying to preserve, but whatever, we are where we are. So we can now do Unix here, and we can say list, files of directory. Great, and now we will get from a string to this went too long. Because the input to this thing is no longer an array, it's now a list. No, It's not a list. It's a LWT stream of strings. So something tells me that we're not going to need to turn an array into a list, but also something tells me that these two things are not going to be the same way we expect them to be. So let's see how we go into this LWT stream module and we find stuff to work with. So these are data streams, right? This convention I read before is not very important. The important bit is that they are over time. They work pretty much like RxJS streams if you used any of them in the past. They are not like input streams. I know, maybe they are. I don't quite know if that is correct. What I'm going to say is that they are lists over time, if that makes any sense to you. If it doesn't, hopefully you'll find something online um, to make this more reasonable for you. And we kind of want to take each one of these elements, right, and add the directory name. So we're going to look for map, and we'll see if we find map anywhere. And we have map here. Great. So that means that we can replace this listing with LWT stream. And what does map do? Map takes a function from A to B and returns an LWT stream of B on the right after you give it one of A. That's good. That means that so far we begin with a there. Oh, we have something that's still wrong. We begin with this, right? With this stream of strings, and then we map over it and we get more streams because, you know, there's not much that file concat is doing for us right now. It's kind of sad. And now we want to partition this into the directories and the files. So let's see if there is a function called partition. And now, because we know there's a module that has utilities, we can just, oh, we can't. Okay. So we have some utilities here, and I'm going to make my terminal a little bigger so you see all the type signatures. But I don't quite see anything that helps us here. Huh. Get while is closed. Iterate between them. Map of array. Pick to list. Okay. All right. So maybe we can achieve something similar, right? By using a little bit of the type system. There is no partition, but if we have map, right, then we essentially can get a path here, right? And we can try to check if the path is a directory. But because this is a blocking call, we can't use this same function. We need to find a function that's very similar but works with promises. So let's take a look inside of LWT Unix and see if there's something like is directory. Okay, no, there isn't. How about LWT IO? It's busy. Okay, so there isn't a higher level function that says if a file is a directory or not. So what can we do? If you know any Unix, and I know I've been learning a lot thanks to this library, there's a function called fstat that I think you can even run. Okay, I don't have it. Fstat, yes, that you can run on a file. Like for example, where am I? Okay, I'm somewhere else on this site. That will give you a lot of information about it. The name, the size, the device it's held on, or so on. And thankfully, this function is actually implemented as a system call, so it's part of your operating system, which means that the Unix module will definitely have a call for it, a function that will work with it. And it can tell us whether the file that we have is a regular file or if it's a directory, right? So we have a regular empty file here, but if we do stat on, for example, public, it will says this thing is a directory, right? Okay, so far so good. Let's see if Unix has anything like this. And we have a bunch of stuff with S, but we do have stat. There you go. And this does take a string, and it returns a promise. It returns a promise, which means it promises us that at some point in the future, we will get these unique stats of this file back, which is good. We can say, let's take the path of this thing, right? And we can pipe it over there. And while we're here, we might as well just do the concatenation in the same step, because why map over the stream twice? We can just map once. And if I save this, did it work? It broke. It broke because this list partition is bad syntax. We have semicolon here, and we don't need this thing anymore. If I save, boom, it did it for us. Great. All right, so we take the path, we add the directory, and then we take the stats. So if we look at the type of this, it begins as a string, it continues as a string, and eventually we end up with this promise. So because this is a promise, we don't have access to the value directly. What we need to do is kind of put a callback on it. And the way to do that is to use something called LWT bind, right? Actually, dot bind, like that. This function over here, as you can see on the signature, it takes a function, sorry, it takes a promise. And if you give it a function that will, and this is a very important bit, it's kind of hard to get right at first, but if it takes a function that will receive a value of the same type that's inside of the promise that you already gave it, and this function has to use that value to come up with a new promise, which means this is how we chain promises together. If we use JavaScript, normally this is .then. This is the value, and then you return something like new promise and something else in here, right? Forgive my JavaScript. Unfortunately, promises in JavaScript are completely broken. Why? Because .then also works for extracting the value outside of it. So if you say like some value dot I don't know, path, right? This is not a promise, and it still works. Why? Because then has two type signatures, right? It takes a function from A to a promise of A, but it also takes a value from A to B, and this is broken. All right, so we know that we get stat. So we can do a lot of things here. One of them will be to essentially call LWT bind, but the bind has this weird way of ordering the arguments where the first thing is the promise and the second thing is the function, and we kind of want to give it the function first. So as it turns out, LWT has this module that defines some operators. Operators like you do piping between functions, or like you do adding two integers together, like 1 plus 2, then plus is the operator. But it really is a function that somewhere you've defined like this, like A, B, like internal addition function of compiler A, B, right? Something like that. This is an implementation detail. The only thing you care about is that the operator is very well defined. Takes two integers, returns an integer. So they've gone lengths to do the same thing, and they have this module called infix that defines a few operators for us. One of them, if we look at the first one, has the exact same signature as what we need, which is takes a promise, right, on the left, and on the right side, it takes a function, which does the next thing. If this got super confusing, please let me know and we can get back to it. But essentially, we will be using this operator, which is the infamous monadic bind operator, to access whatever is inside of stat, right? After stat is resolved for us. Essentially, here we have, we can give it a function that now can use stat. The only condition is that this function needs to return a promise. If we save, it's going to put it at the end because, but don't worry about it. Now, what we need to check here is that the what we need to check here is that something inside of this stat object, right, is either a file, regular empty file like we see here, or a folder. And I don't know this by heart, so I'll just try to let the compiler figure it out for me. So stat has a bunch of properties. One of them is a kind, which from the looks of it, it's a file kind, which sounds to me like it will be something. All right, so that's the end of the value. So okay, from the looks of it, I will have to take a look at the docs and see what the possible options are. But because there will be options, pretty sure there will be options, I will want to take a look at the module it comes from. And because it comes from Unix, if you do a switch and you do auto-completion here, we should have a bunch of things that we can take a look at. Honestly, these are way too many, much more than I expected them to be. So we will, all right. So we will just go to the docs and take and search. This is the tool, by the way, Oak, where we will be doing this progress. So have a look at it, clone it, build it, do whatever you feel like with it. Start it, fork it a lot, please. Fork it and just mess up with it, just play around. That's sort of the best way to learn these things. We'll do camel, Unix, and we'll open these docs. And we will look for stat. Actually, file kind. So file kind is a union, as we expected, that has a few things. And one of them is a directory, and the other one is regular file. So we are really interested in the directories and not in regular files, so we can match on this thing and just ignore the rest. So if we do this thing here, if we have a directory, then we can just use a variant to say this will be a dir and put the name of the path here. And if it would be anything else for now, let's just say it's a file. Why do we want to use a variant? We want to use a variant to be able to very quickly partition this list later on, because right now we're going through all of the files kind of concurrently. We don't know in which order, but then at some point we want to put them all together in some sort of list. And knowing whether they are a directory or a file is very helpful. But there's a problem here, and is that we need to define a type, like type T, and then we'll select dir, and this is a string, and so on. And it might be just as useful to define it as a polymorphic variant, where we don't need to define the type, and that should be okay. All right, so after we have defined that this is a directory or a path, we realize that doing more stuff in this function, right, we get a little bit convoluted, cloaked. I don't want to like go down this path and do a bunch more things and go down this path doing some more stuff as well. I kind of just want to end this there, right? I want to end this function here. But because I'm not returning a promise, I need to use a different operator. I need to essentially use the map function. I want to change the things inside the promise without actually turning it into a new promise. And I could do this by doing LWT map and then passing in the function here. But because we have operators already, we might as well use the map operator. For any of you that have worked with Haskell, this will look weird. I think in Haskell, this is the map operator, but it's close enough. So if we save, we'll see that path is a string, and the next thing that we have here is another string, and then we get the stats, which is a promise that when we get the stats, something will happen. And then we'll just map over this, and you'll see at the bottom left how we change from Unix.stats inside of the promise to one of these two polymorphic variants. It could be a dir, or it could be a file. And that's brilliant. That's kind of all of what we need right now. Great, I think we're good in time. So essentially, after we do this mapping, right? If we go back at the top, we'll see that we begin with a string and we come up with list of directories, and then we end up with this stream of promises, right? Of directory names and file names. And this is where thing gets, oh no, Ulrich, you, you, actually don't need to. You 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 actually or do you? Huh. I think you don't. Yes. We do have a type error, and you'll see there, because we are expecting a tuple, and we're returning this thing that it doesn't know about. So for the time being, I think that we can, I don't know, sometimes I am, but most of the time I'm just terribly, terribly wrong. Anyways, the interesting bit here is that we can decide whether to collect all of this information and then keep processing it normally, right? Or whether we want to continue saying, all right, after some time, but immediately when you give me the information of whether a particular file is a directory or just a file, then do something else. If it's a file, print it. If it's a directory, then recurse. And that's where things get sort of tricky. So let's do first the collecting into a list, and after we do the collection into a list, then we can continue with we can evaluate, and we'll see if it's fast enough, then it's good, and if it's not fast enough, then we can take a look at the other approach. It could also be that this is even slower, right? All right, so after we've gone through this and we have this stream, we can use the LWT stream module function to list to turn a stream, right, into, if you see here, it takes a stream of something and it returns you a promise, a single promise of a whole list of things. So this is like a collector. This is like a reducing. This is like promise.all in JavaScript, where you give it a bunch of promises, right? And then you get a bunch of results in the callback, like res1, res2, and so on. But where the list of promises is also a promise. You don't know the size, it just varies all the time. Okay, so now if we look at the type of this whole thing, right? Oops. If we start here, it is a list. Sorry, it's a promise that at some point we will have a list, and that list will will be a promise that some things will be directories and some things will be file. Already confused? This is not going to get any better than this. So let me know if you need me to explain something else again, or if you need me to slow something down or speed something up. All right. So something that we can do is, what is something that we can do? Right. Is we can access this value inside of the promise by using the bind operator, which you saw before. And then in here, we will get a list of paths. And this list of paths will be a list of promises. So if we could only turn this around, right? If we could only wait for all of these promises to resolve and just have a list of the values that the promises promised us, then we will be in a much, much nicer place. So let's take a look at LWT and let's see what functions does it have that if you give it a list of promises, it gives you a promise of one thing. So we're looking for things that begin with the list, right? Like this one, or this one, or this one over here. Okay, so we have some. There is also one called npick, and there's also one called pick. So there's quite a few of them that maybe we can use. We have wrap, we have unit state, and then we have some types and values defined there. Interesting. Okay, so let's have a look at LWT stream and see if there's something in that module that can help us here. So we're looking for something that, again, takes a list of promises. So I don't see any that on the left. Okay, no, this is choose, combine, no, concat, no, flatten, no, get available, map. I wonder if we'll need to use something else instead. So let's see if we have a fold operator here. We have a list module. Let's see what's in there. We are looking again for something that begins with a list of promises. Okay, we have fold, and I think fold is the closest thing that we have to what we want. And it looks like maybe we'll have to use fold for this, which means that we will take this list of promises, right? And we will concatenate each one of them so that when one is finished, right, then it will wait for the next one to be finished, and so on and so forth until they're all finished, and then all of those values can be put inside of a regular list. I am not entirely in love with this, but I see something that I really like, and is that I see a partition function here as well. This is interesting because we already have a list of promises, right? So maybe there's something that we can work around there. So if we turn this into a list, we have here a list of promises. Oh, but of course, this is just a list, which means that we can 100% just call the regular list fold with this, where we have file A and file B, right? Let's just return A for a second there so that it type checks. And we want to start with something like an empty list, right? And we want to use the paths as an input. So if I save this, right? And of course, the empty list will be the accumulator, and then this will be the path promise. So let's call it P. So this might be a little confusing for some people. Let me know if it is, and I can try to find a different explanation for it. But essentially, because we have a list of promises, what we need to do is say, given an empty list, right, and one promise, we will wait for that promise to finish, and when that promise is finished, then we will have a path, and we will be given this path in a function, right? Remember that the operator takes a promise on the left and a function on the right. And hi, there's someone new there. Hello, viable clan member. That's a very Ron Swanson kind of name to have. Oh yes, I'm South American. I'm really loud. I apologize for that. There's not much I can do. Oh, did I misread that? Your volume is lower than other channels. Okay, that is something that can go unnoticed or unattended. Sound preferences. Can I change the volume here? Does this even work? Input volume. What about now? Is that better? I'm gonna put it at 80%. You let me know how it goes, and I'm gonna check the battery of this bad boys. Ooh, 5% better. All right, let's do one last shot. Let me know if you hear me when I change to my internal microphone. 1, 2. That's funny. Hello. Is it back on? Yes, it's back on. I am back. Okay. Um, Ulrich, remember to lower the volume, and I'll try to continue the stream while my headphones have. Not today. Okay. I'll raise this thing a little bit. Oh, yeah, I actually boosted the volume a little bit. Anyways, what I was saying is that we have a list of promises right here. And it's not going to work until I finish typing this thing. And for each promise, we want to wait until it has a path. And then what we want to do is we want to put the path inside of the list, right? Path, and then continue with the accumulator. That's sort of the gist of this function. Now, I reckon that you might have a problem here if we take a look at paths. And is that list fold expect you to come up with a list of bees. And after we sequence this, right, the first fold does not know what to do, with the promise. Oh, viable clan member. One sec. I'm going to open a new file on the right. FT reason. Essentially, imagine you defined a function called plus somewhere that takes an A and a B and calls something like camel internal add numbers, right? A, B. And this is something the compiler will figure out how to implement. But for syntax purposes, you have this operator. So you can call 1 plus 2. And this essentially is the same thing as doing plus 1, 2, right? The operator that you see is this one. It's called bind. And it's a monadic operator that comes from LWT bind. So writing A, B, C is essentially the same thing as calling LWT.bind A and then B, C. It's just it lets you do this thing where you can chain things together, F, G. Whereas if you had to do this thing with this syntax, it would be a royal pain in the ass. Okay, so we're done there. And as I was saying, fold left will work for what we want, but because each one of the steps returns a promise, it won't, which means we need to use LWT list. And in here, we can use fold left. And now if we do that, then I think this should compile, but it didn't. Um, hmm. Huh. Interesting. So what if I told you that you're a list of their string and file string? Will you complain then? Sorry, the type checking is having some trouble, and I want to know what's the problem. Okay. So line 30, it says that this function, right, which takes a list of something and an accumulator of something and returns a promise. I do not know if there is a property of it being reasonable other than being reason code, reasonml. Have a look, reasonml.github.io, I guess. But if you look at some of the other streams, then you might get an idea of why it's reasonable. I attempt to decompose the problems into very small parts and then go over them slowly. So like iterating over things. Oh, come on, it's not just a pun. I'm trying to be reasonable here, people. Come on. All right, but yeah, it is a pun. I love puns. I've been told I should have been born in Gothenburg. because of the pawns. So what's strange here is that this path, this is not automatically learning that it is one of these things. But all right, so let's look at the error. So 30 has line 40, line 30, character 44, and of course, we need to return a promise. If we don't return a promise, then this will never be sequenced, and I wonder if we can just map over the contents of this promise. Good, that's better. So now this thing will work and will tell us, we go from a list of this thing, right, to, look at that, the inverted, from to a promise of this thing, which means we can absolutely continue executing. But before we do so, let's give these things a name. I actually want to call this function tag file. So I'm going to do let tag, and this thing will get some stats, and it will return you the rest. So if you move this around, and then we can just say, and then tag. Much more reasonable. And we can just say Unix stat and return. I don't want to tell you what you are. Okay, so I'm just going to do a local opening here. Open Unix. Boom, and now it knows about it. Great. Cool. So now we have the map, and we have the concat here with the path, and then we do Unix stat. And I still don't quite like the way that this broke down, but we can fix this in a second. And now after that, we take all of the promises of directories and files, and we turn this into promise of directories and files. So it sounds the same, but one is a list of promises, the other one is a promise of a list. And that's amazing. Why? Because after we have the promise of a list, we can partition the list. Yes, precisely. So we can take the contents of this promise and we can say, just partition this list. And then we get a path, and we can just do something very silly, but we can just say path. If the path is a directory, right, of whatever as there, we will return true. And this is completely arbitrary, right? And if it's a file, actually, yeah, it's a file, we return false. And we don't even need to know these things. We can ignore the contents. So if we save, this is missing a brace there. Boom. So line 6 is complaining about something. It says this expression has string stats. What the hell? Oh, of course, we're missing the path. That's scary. So if we give it a path, okay, so I think I want it to do a little bit more. I think I want it to return the promise to me. So stat. Bear with me for a second while I refactor this bit. I'm just gonna take some things around. If I save, it's still broken. But if I put a parenthesis after this bit and we remove that bit over there, good. So if you give me a path, I will try to stat that path, and then I will try to return a list of. I will try to tell you if it's a file or not. And now this looks much better. We take the path, we concatenate the directory, and then we tag the file with dir or file, right? Sorry, could you repeat that? Isn't paths, pipe? You mean in line 26 or in line 32? Line 29? Oh yes, you're correct. We could essentially get rid of that and get rid of this thing, and that thing over there can go away. Brilliant. Much nicer. Thank you so much for that, Ulrich. You are a genius. Yes, we could have done this all along. So essentially, we want to do kind of the same thing here. Path. No, we can't do it there. All right, so we take the path, we concatenate for each path the directory, we tag them, we turn this into a list by collecting each one of the elements. And then we fold the list by making sure that we get each one of the elements into an array. And now I'm wondering if LWT stream doesn't have a fold that we could use. And it does actually. It does. We could have just used this. So like if I, oh no, sorry. I think we can't because we need it to be a list to partition it. No, I think we will have to do function for that. So you can do function, actually fun, like that. I was gonna call this is there, but this works too. Like if you want to do it this way. Cool. So now so far, if we take a look at this, we have a directory, and then we have a stream of strings, which are all the files in that directory, and then we get a stream of promises of whether each one of them is a directory or. Yeah, you're definitely right. I think this is more readable than what we had before. And then we take this stream of promises of directories and files, and we turn it into a list. And of course, that's going to be a promise as well. And we wait for the promise so that we get the full list, and then we operate on that list of promises, and we turn all of them into a promise of a list, so that then we just have to wait on one thing that will tell us the names of all of the directories and files in that folder. And then after that, we will just take that list and partition it, and some of them will be directories and some of them will be files. But what I wanted to actually get to is to be able to do this, right? So that you get a tuple back from this partitioning, and the partition function should allow us to do this. Which I think reads very nicely. I mean, you can't mismatch these things. You have to give it dir and file, so you can't. I mean, if you go all the way to do this, right, then I mean it's good luck in a lot of things, but but it should be pretty evident that something is wrong if you have the wrong names in there. Fortunately, if we start over here again and we go all the way down there, this doesn't seem to help us there. It just seems to say that there will be a tuple and some things. Yeah. I guess what we can do is we can extract some things in here, right? So the next thing we want to do is we get the partitions. So, I mean, we don't really need to do this on the left. In fact, we don't even need to save this in a variable, and I would argue that we won't be able to. But I want to get to the point where we know that we can't. So essentially, we have some dirs on the left and we have some files on the right. And you'll see this double parenthesis means there is one input and the input is a tuple. And the tuple has two elements. So there's dirs and there's files. And after we do this, then we can decide to print some files or not. I mean, we need to essentially return something back. We need to return a list of something, right? So the question is, do we concatenate everything together here, and where do we do the recursion? So we know that we have this, and this will be a list of directories, even though the type is telling us that it can be either a directory or files. Unfortunately, after we partition, the type system doesn't know that it should send these two things separate ways. I mean, we could tell it that now it's going to be, you know, the output is going to be a list of, oops, my headphone is going to die soon, damn it. But I think that this should be okay for now. So essentially, we want to take these directories and we want to recurse over them. So we want to map each one of them to a promise by calling find all, right? List.map. And once we're done with all of them, wait, I'm actually really confused here. I mean, there's a few levels of indirection and of waiting. Like, we wait for the files, and then we wait for each one of the files to come back and be told to us, hey, I'm a good file, I'm a directory, or I'm a folder. Let me know if you still hear me. I'm gonna try to charge half the headphones because I have 13 and 10% EU. Can you still hear me? Yes, it still sounds like it's recording something. Okay. Hopefully this technique will work, and then I'll be able to continue streaming almost indefinitely. Brilliant. Thank you. 11 more 11. How do you pronounce your name? 11 more 11. Thanks for following, by the way. All right. So, I don't know. There's something iffy about this. Like, we're trying to collect this stream of things into a list, but then we'll have to stream each one of them again and collect them back into a list again. What if we could just return you a stream of all of the files, you know? And as long as there are more files, we continue to return files. To me, that sounds like it makes more sense. Which would mean we don't really need to fold anything. The only thing that we need to do is after we map the stream, right? Then all of a sudden this thing became this stream of, oh, these are files and these are directories. We can use this information already to start to recurse, to call find all on all of the directories that we find are directories, right? Why would we wait to collect everything to be able to start looking for more files inside of the new directories? That doesn't make a lot of sense to me. So here we have the path, and we can also use a fun here. And this will either be a directory, right? And if we do have a directory, we kind of just want to say find all. But if we have a file, actually here we just want to take the file name out. Then, and this was not going to be able to be there, I'm going to call this D. If we have a file, then we want to just return the file. Like the only use of this distinction between directories and files is to know when to recurse, right? And if we essentially pattern match on them here, then we're eliminating them, and then we don't need them anymore, which means here we should be able to just return file. Which is kind of confusing because this thing is obviously a string, right? But this thing is going to be something else. This thing is going to be, if I make comment here, this was going to be an LWT stream of string. And this thing here is really just a string. Like that's how we are defining this thing here, right? If we go to path, this is the string inside of it. So maybe a cheap trick would be to just turn this into a stream. Create, bound, filter, find, return, result. What's result? No. Let's see what we have. To list, big parse of list, of array, terminate, parse, next. Get from false. All right, I am pretty sure there's a better way of doing this somewhere, but I think that we can use of list right now and just put this file in list. So now, now we actually get a lot of code out because we begin with a directory and we come up with a list of files, a stream of files in line 25, and we tag all of them, and as soon as they are available, we take a look at the tag. Wait a moment. I have a question to myself and to all of you. What is the type of X? And I think the type of X is going to be a promise. But it's not even telling me because we have so much code that it doesn't know what's what. So let me just remove this little bit over here, and don't worry about it. Vim has an impeccable history, so we can go back. But yes, all right. So this is a promise, which maybe means we don't want to do map directly, but instead we want to just do this. So we get a stream out of this thing, right? And then for each element of a stream, then we want to turn it into the next thing. Oops. Which is we will get a path, we concatenate, we tag. When we tag, we get a promise, and then we get rid of the information from the tags, and we return another stream. Right? So find all will return a promise and a string. Oh God, what is going on with the words today? It's going to be an LWT stream of T string. That's what it's going to return. Because that's what we want find all to return. We want it to go from a list of string, right, to a stream of T of strings. So essentially, give me each one of the files as fast as you can give it to me, and just forget about everything else. So I'm gonna open the other shell so we see some of the errors that we have. We no longer want to distinguish between these two things because we already are recursing, and if we take a look at the type of this expression, it's clearly a little convoluted. It's a stream of promises of streams of of strings. So we need to flatten some of these things out. Let's see if we have anything like bind here. Bounded push, definitely not what I had in mind. So we have something called flatten. No. so this is a promise. Do we have anything like map? Huh. Map s. If your function returns a promise, this will turn a stream of a into a stream of whatever your promise returns. And that looks a lot more like what we want. So if we look at the full type again, now we have a stream of a stream. Huh, okay, I'm liking this. And I think we saw a function before that takes two streams and returns a single one. I mean, takes a stream of streams and returns a single one. And if it's not called flatten, no, this is a stream of lists. It must be concat. Aha! Takes a stream of streams and returns one stream back. Brilliant. Awesome. So this means that this thing over here will be a string that becomes a list of files in a directory, right? And then we turn this into either a recursion for more files, right? Or we turn it into, a stream of one file here, which is the current file. And then after that, we just concatenate these two streams and we get the stream of all of the folders for as long as we can recurse, which eventually means that this file subdirectory will be empty. And if it's empty, then map s will never run, and which means we will never recurse, and then we will concat the empty streams and the stream will be finished, which means we need to remove this thing. Okay. And it appears that we have defined a function oops, sorry. If I remove the type, it will come up with one type that then I can take a look at. Okay, that's the type that I wanted. And in line 30, it tells us this, right, okay. So when we recurse, we should not be passing the whole directory, we should just be passing the name that's inside. Well, that makes sense. If we save this, then great. So line 37, it's not complaining because our find all function is completely asynchronous, right? But we're not making use of it nicely. Why? Because we now return this stream, and then we need to treat it as a stream, which means we need to do LWT stream and then map, and then we can do, actually maybe we want to do iter. Yeah, there is something called iter that we can use to print everything. And then that works. Okay, so any bets on what we're expecting to see here? Let me also install. Okay, sorry. I thought I was waiting for the microphone to pick up. Thank you, Hi Chem T07 for following. And all right, so no bets on what's going to happen when we run this thing. The last thing we did when we run, where's the find, what was 14,000 files. Jesus. Come on, man. We can't do that to the people. The people need to know. All right. So we expect to see, I don't know, a bunch of files maybe, right? So let's just run it first without anything so we see what happens. If we do that, this is misleading. So what's happened? We built a promise of finding all the files, and we've gone through this stream trying to iterate over everything. But here's the thing. When we build these promises, as we said before, we're actually not doing any work just yet. We're just building a value, building a data structure, right, that will eventually get the work done for us. So what we need to do is to tell this LWT to please run this value so that we can get some of the output out. And if we look at the example that we saw somewhere inside here, oh, so many comments. This is so nice to see. Thank you so much for watching and following and commenting and everything. And I see no forks. People go and fork these things so you can play around with it later. That's an order, like indirect order. I mean, a direct order. And value TM. Yes, I like that. So if we saw in the example here, what's it in the example? Or no, in the main module, we saw that we are actually calling something LWT main.run. So we can take a look at what that is somewhere, main.run. And it's a function that takes a promise and returns the value that's inside the promise. And how does it do that? It does that by actually waiting for the promise to resolve. Boom. So if you work with futures or completable futures or completion stages in Java or Scala, then you have the get function that does that for you, and also join function. Here we have LWT main run. And because it takes a promise, we can take a look at what the hell do we have here that returns a promise. So this first thing here is a string, and then we turn it into a stream of strings, and then we turn it into exactly the thing that we need, the LWT T unit. So if we just pipe this into main.run, honestly, I'm willing to change the name of one of these functions just to have it vertically stacked. That's how willing I am. If we add run at the end, then running this again will, sorry, I need to install it so that I can use the name oak. You can see that the compilation succeeded. So if we install it and we run it again, boom, we get something very, very wrong. And that's cool. That's cool, that's cool. So why could this be happening? Who can tell me why we have a name too long here? I think I know already, but I also think that Ulrich might be able to pick up why. What's going on? I'll take a sip of water in the meantime. And thank you, my sponsors, the universe, for creating water. It's like 70% of my body already. Drink it now, but not too much. Nothing? Okay. So, oh, Pixel here came back and named too long. All right. So for the avid of you, or for the reasonable of you, exactly, we're recursing of the same thing over and over again. And the thing that we're recursing on is nothing more than the current directory, the dot. So essentially what this is saying is that if you actually try to go to this folder, right, and I'm going to copy and paste this thing here. If you try to go here, then you're in the same place, but the stat call fails. The name is too long. Hopefully that makes some sense. All right, so let's clean the terminal and say If we actually have a path that is the dot, then let's just return, the dot as a string. But otherwise, any other directory, we should stream over. So this is the base case of our recursion. Oops, there you go. Hopefully that made some sense. And because my LCD is kicking in, these are base cases and this is the recursive step. Does that make sense? Yes? No? We built. Let's install. And I have a typo somewhere. Yes. The typo is in the name here. Cool. So if we run this again, then we should see some, oh my God, it's still broken and it's because I forgot to install it. Sorry. My bad. I should automate that step so it builds and installs automatically. All right, are you ready? Who here bets that this is gonna run? Say it will or it won't or whatever you feel like. Any emoji that you feel represents any of the options. I know, right? It's one of the most elegant ways of generating heat. You people are really uninteractive. Okay, so I'm just gonna run it. And we still have this thing. Why is it? Why do we have this thing? So my thinking is that the thing we're gonna pattern match on here is actually gonna be dot slash. I may be wrong, but it's certainly possible. And what's even worse is that this might actually be dot slash dot. It looks like a hand flipping someone off. Why do I think this? I think this because we begin with a path, right? Like dot, and we concatenate the directory to it. So if the path in here was dot, and then here the directory was dot, then we just did this, right? So that's a base case. And yes, I'm fully aware that I said, oh, I know the solution. And then while I was explaining it, I changed the solution. So don't give me shit for it, please. But if we run this again after installing it, then it still fails. But hey, we got the dot. And now we have another edge case, which is the dot dot. And if we build and install this thing and we run it, then we have another edge case, which is the first folder and then dot 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 dot. So I think you're getting the pattern here. We are definitely trying to recurse. In fact, we're recursing way too fast and way too deep, but we're recursing only over the most terrible of the values. Uh, we don't want to recurse over that one. We want to recurse over anything else but that one. Um, so my thinking is, how can we tell that we are about to go one level too deep? So let's say we are in, I'm going to just use stat for this example. Let's say we're in dot, right? And we find that the folder, next folder is called series, right? And then this is the new base path. And then we have dot. And that is something that is there, right? But this is a folder. So we need to recurse. And then we have a dot again, right? And then this is something that we need to recurse. What is the common denominator of all of these recursive cases that end up in an infinite loop that eventually kills the stat? What do all of these folders have in common? It's more obvious than you think it is. Like it's literally written right there. What's the one thing that's in common with all of them? Yes, but what is the dot? If I do LA, I see templates and public, and I see dot. What is this dot? Right. So you're still thinking that this folder is a magic pointer, right? But it's really just a folder. The operating system does some machinery inside. So this folder has a base name, which means the base name, right, of the directory can't be dot. If the base name is dot, we should not recurse again. And I realize that I've said that very, what do you say, confidently, but I have no idea if it's right. So I'm expecting to say base name here and get a dot back. Boom. Okay. So essentially, it doesn't matter how many depth, how deep the path is in here, right? Um, as long as the base name of this D is a dot, or in case of a dot dot, a dot dot, we should not recurse. Which leads me to think that if this is D, right, then maybe we want to do something inside of here before we recurse. Maybe we want to say, all right, if we get the base name of the string, and I think file name has something for this. Ooh, look at that, base name, dot, right? And if we switch on it, and I know that some people don't like having multiple levels of switching, but come on, it's not that bad. It's better than ifs and else's. And when we have a dot, or when we have a dot dot, then we'll just return that thing. And I'm just as surprised as you are, actually, as the prime of LWT stream of list. But any other folder that we find, right? For anything else, we should just recurse find all with D. Boom. Does this make sense? I hope this makes sense. It barely made sense to me right now that I'm figuring it out with you. So we'll see how it goes. I'm gonna install this thing again, and I'm gonna run it. And voila, we get a bunch of crap. So remember that if we did the find call somewhere here, find, we got 14,385 files. Do you want to bet on whether we get more or less? No? Okay. Well, let's run it and see how it goes. I think we will get more files. We got less files. Yes. I wonder why. What files are we ignoring? And I'm just going to do a small test, and I'm going to say, just give me the folders, just directories. Ignore all of the files. And this should be the difference. So 185, 187. So that would be 185 plus dot and dot dot. So my guess is that we should add, whenever we have oh my god, how do we, yes, exactly, two less, which is dot and dot dot. How the hell do we add here, right? We want to add the current directory. I guess we could do something nasty like concat, like that. Super gross. Oh, this actually does combine. Sorry. Well, I don't know what combine does. Okay, so sometimes the compiler just, it's too good at calling me out on my shit. But essentially, if we find that we have a file, or if we find that we have directories, right, we will be returning a stream of, a promise of streams. So how can we push this extra value, this one little more there? Yeah, we could do that. That sounds like a good idea. So we have a dir here, right? And we want to get this stream and add something to it. So let's see what we have in the stream. To list of array and junk. Oh, don't worry, man, it's fine. We're all here doing the best we can. Flatten, find map. Create. Combine. Append. So append sounds like something we could use here at the very end of everything to just add the directories that we were missing. And this is like, I'm pretty sure there are better ways of doing this. That compiled. So if we run this thing now, we have one extra file. Yes, we have more files than before. Okay, time to check what the hell happened. If we do an A, and we put everything in there sorted, and if we do a temp B, right, and then we diff the temp A and the temp B, they are very different files. Oh, but even after sorting them, what the hell? Why would that happen? You know what? I'm gonna trust Vim to sort things. This is probably a bad idea. But it sorted everything and it's 187 lines. And if I open temp A and I sort everything, I think I know exactly what the problem is. And is that find, it seems to be ignoring. What? These are very different files. Oh, wait, I think I'm doing something very wrong. So find here, if we sort it and we put it in temp B, and oak here, if we sort it and we put it in temp A, then doing a diff of temp A and temp B should be that we have one file. Oh, thank you so much for that. I didn't realize until after I saw it. I mean, I didn't read the comment until after I realized. So it looks like we want to ignore this dot dot, which is curious. I would say that we can do that so that we have the exact same outputs. So if we have a dot dot, right, then we'll just return an empty string. Do we have something called empty? I think it will be of list, and then you just give it an empty list. And of course, we don't need any of this. So if we install it again and we run oak, where is it? And if we run find, boom. Round of applause, everybody. Woo! Nice. Almost in time. We have a version of this tool that works completely asynchronously. That's amazing. But now let's see if it actually is faster. We don't know if it's faster than the other one. So we knew, right, that our previous tool was over 100 milliseconds. And if I go back into in time, here are the benchmarks, if you want to call them that we did. So I'm going to copy these things, and I'm going to go into a file called benchmd, and I'm going to put them all in there. Boom. And I'm going to go markdown thingy for making code look codey. And then this is the synchronous version. Synchronous or blocking IO. What that's not blocking. That's not how you spell blocking. IO version, right? And then we're gonna check the time it takes for. Sorry, DevNull. That's what we were running. We're gonna check the time it takes for the new version to run. And I actually expect this to be much slower, but we'll see. And it's really slow. It's so much slower. Yeah, it's insanely slower. We were expecting to make something was even faster, but we got something that's much, much slower. And this is only a testament to how bad my LWT skills are. There's possibly tons of things that we can do here to make sure that when we read things and when we concatenate streams and whatnot, we do it in a very efficient way that I'm just not aware of. Yes, exactly. It's ours. So I'm just gonna take this code right now. And unfortunately, we don't have a lot of time. I need to be going soon. It's 51 already. We've been here for over almost 3 hours. And we don't have time to test the version of this tool that works in parallel using multiple cores, which is also possibly something the Find is doing. I do not know about that. We'll see. But we can definitely give it a shot some other time. So I'm gonna schedule another event sometime in the future, maybe in a few weeks when everyone's back from vacation and holidays, and everyone has their bellies full and their hearts warm, and it's all nice. And we might talk about parallel computing with nproc. Which, by the way, if you're interested in something that does work in parallel, you can take a look at Cactus. The source code is not that messy and it's fairly small. I think it should be if I call clock here, ignore all of the files. Oh my god, what is it doing? No. Clock source. There you go. It's 600 lines of reason, and it's a composable static site generator that I've been talking about way too much. I should shut up about it, right? But it's a great tool for learning. So yeah, I think this is the end of the stream. We've covered how to build a tool from scratch, how to run it, how to do some very bare bone benchmarkings with time. Uh, we will definitely schedule as well another meetup. We also run the recent ML Stockholm meetup. Follow us on Twitter. It's pretty cool. We never post anything, but we retweet stuff. No, I did not make a pun. I didn't make a pun. Okay, I made a pun. Uh, follow Reasonable Coder on Twitch if you like it, and just leave some comments. And if you want to host it at some point, then feel free to do so as well. You can follow me on Twitter if you want, and please hack on your free time if you have some on the tool. The source code is completely available here in Ostera/Oak. You can fork it. I've seen the number of forks is still at 0, so please go ahead and fork this crap. Thank you, Pixel Hero, for the Twitter. Actually, I'm just gonna post it like the link here so people don't escape. And if you want to follow me, you can. Where is it? Kidaf? No. What the hell am I doing? Ostera. You can follow me. No, that's not me. That's not me. Don't follow that one. That one is someone else that took my name. This is me. I had to change the name at some point. Anyways, whatever. Thank you very much for being here. Thank you very much for the comments and the help. Thank you so much, Anton Bachin and Ann Montero, for the help in preparing this stream, pointing me to the right places in LWT. And thank you, Universe, for creating water. It's delicious. And stay reasonable. Okay? Ciao.